Now let's discuss on present value annuities. If we look at our information sheet, there are two formulas for our annuities, alright? And here, this is what we have seen in our present value annuities. I hope you can see it, right? Now then here, this is what we are going to learn now. That is present value annuities. Now, what is the essential difference between present value and future value? It is that the present value means there is a transaction as the amount, the bulk amount has taken place immediately. That is the present value. When it comes to the future value, the savings that I make and I'm getting the accumulated amount gets in the future. For example, I am making a savings in my provident fund. That is, I am going to get the money, the bulk amount in future. It might be 400,000, can be 4 million rands. Right? That is the future value. I am getting that money, the bulk amount. I am making small savings and getting the bulk amount in future. Present value means the value that I get today, the amount that I get today. There is immediate outlay of funds. For example, there is a disbursement of loan, right? And there's another way of also the huge investment I make. I make 4 or 5 million rands, and then I won a lotto. So I get 3 million rands. I invest that money in the bank, or in some schemes where that institution is going to pay me back every month. That is also a present value transaction. There's immediate outlay of funds. Let's look at this example question here. Kate made a deposit into her account that earns 10% per annum. She withdraws 1,000 rands from her account every year for the next 3 years. How much deposit she made initially? Now, when I look at the question, there is a deposit, alright? Now, if you feel the deposit is necessary, does not mean that I must use the future value formula. Understand the difference now. When the deposit is X, the X in the future value X, right? The X in the future value. I'm talking about the future value, right? The X deposit is made. If that is the X, then this X must look at this X. What is happening to the annuity? If the annuity is deposited, right? If the annuity is a deposit, then it's future value. Then it is future value. Now, what is annuity here? Annuity, I'm withdrawing, right? This is withdrawal of the money. So, when this withdrawal, deposit withdrawal, right? Withdrawal or repayment. If you come across this word withdrawal or repayment, then it is called and on annuity, look at the word annuity. Don't look at the bulk amount, the monthly installments. Monthly installments is deposit, right? That means I'm going to get the huge amount in future. Withdrawal means I'm withdrawing the money, right? Or repayment, I'm repaying some amount that I made for the amount that I borrowed. That is the present value. There is a way I distinguish between future value and present value, which formula to use. So I am going to use the present value. We are going to find the present value because the Kate already made a deposit into the account, and in future she is withdrawing the money, right? And that is why we use the present value. So she made a deposit today. Right? And she's withdrawing 1,000 rands every year for the next 3 years. So there is a withdrawal. X is in future. X is happening always in future days. But the outlay of funds is happening immediately, then we use the present value. Okay. We know amount, right? Future value, this is present value, right? 1 plus I to the power of n, right? This is my future value, this is my present value in the case of the compound interest formula. Now here we assume 1000 rands in the term of timeline, right? Now that is I am going to withdraw here. So here I have to withdraw 1000 rands, right? I am withdrawing 1000 rands at the end of 3 years, and at the end of 3 years, then after 3 years, what happens when I make the withdrawal of 1000 rands, my account becomes zero, right? Now here, what is happening? How will I calculate the initial amount? This is what we have to calculate the initial amount. So I made the initial amount, I have to calculate this amount. So if I take only the aspect of the first year for each of these years, how can I calculate the values here? What I'll do here, using the timeline property, right? Therefore, how we calculate the present value? Present value is A times 1 plus I to the power of negative n. Those who remember this, right? That is, P is equal to future value 1 plus I to the power of negative n. Right? So what is here? I am withdrawing how much money here? I am withdrawing 1000 rands. So here this is 1000 rands, and for how many years? 1 year, right? For 1 year. This has to be the principal if I want to withdraw for 1 year, and the balance becomes zero. This has to, and add 1 plus I to the power of negative 2. So if I add them, this will be the balance for the amount that I have to make, deposit I have to make, so that the balance is zero at the end of 2 years, and then plus 1000 1 plus I to the power of negative 3. This will make me the initial deposit for 3 years. So at the end of 3 years, balance becomes nil. So this is how I get the initial amount, and which we call them as the present value. So if you look at this, observe this carefully, this is nothing but my geometric series. Of course, my interest is 1 plus I to the power of negative 1. Let me remove this unwanted the formula sheet here. Now this is what I got. This is what I have seen here, the present value. Now if you look at the formula, is a geometric series, and then I have to apply the properties of the geometric series to find the sum. So here, if you see, look at the sum here. My sum for three terms, and my first term is 1 plus I to the power of negative 1, right? And 1 minus 1 plus I to the how much it is? 3, right? There are 3 terms, so it is to the power of 3. This is my common ratio is this one, right? And to the power of 3 divided by my common ratio is 1 plus I to the power of negative 1. This is 1 minus, right? 1 minus, and then this is going to be my 1000, right? And I bring the 1 minus has to be 1 minus 1 minus sum of geometric series 1 minus 1 plus I to the power of negative 1 to the power of becomes negative 3 here, and divided by what I do here, I 1 plus I use the properties of the exponents, and I write the denominator, right? Positive exponent 1 plus I to the power of negative 1. Now within this I open these brackets here, so 1000 times 1. Oh, again why I am writing this plus here, supposed to be minus. So 1 minus 1 plus I to the power of negative 3, and I expand this, so it becomes 1 plus I. So if I expand this, what will happen? This becomes 1 plus I, and this becomes 1, and then I can simplify. So this is 1 plus I minus 1, right? and therefore I will reach this here 1001 1 minus, oh, I wrote it very correctly, minus 3 divided by I. So my future present value formula here is, present value formula is X is the installment amount, the amount that I'm going to repay, or the amount that I'm going to withdraw is minus N whole divided by I. So this is my present value formula. This is our present value formula. Alright. What does P stands for? P stands for, here it stands for the present value. Value today, right? We also call them as outstanding balance. What do you mean by outstanding balance is that the balance I need to repay, right, in a period of n by making n period of payments, n number of payments. So when I make n number of payments, I'll be able to clear my balance with a given interest rate. And X is my repayments or withdrawals. So understand the key words and that tells me, and that this, I have to use a present value formula, is a repayment. Loan account is, understands, is a present value. Bond repayment, yes. Next is I. I is my interest rate. I is my interest rate. N. N is the number of period. Right? Number of periods of repayment. Right. So, in other words, what we are going to do here is, these are the number of repayments that is still to be made, or these are outstanding, right? Or payments left. I can say that the payments left. Right? Balance number of payments is N. So this is the understanding of the present value formula. And remember, whenever I repeat, whatever we have learned, whatever formula that we are learning on annuities is the end period annuity, that is the payment starts after 1 month of the contract. That's what we have learned. And we are only learning that the formula, these two formulas are based on that. Now, some interesting aspects on present value formula. Of course, this is also applicable for future value, but it's more understanding is required on present value. I want you to understand further on what is happening in a loan account, especially in loan account. This is my principal. I borrowed this 50,000 rands for a period of 16 months, and my rate of interest is 7.5%, and my repayment amount is 1,001.90. Now, what will happen if I borrow in January, right? This 50,000 rands. So my balance in my account, right, on January 1st is 50,000 rands. What will happen on the first repayment, that is on February? I repay 1,001 rands and 90 cents. Remember, my repayment starts after 1 month of availing the loan. Now, there are two components of this repayment amount. So my repayment amount here in this case is 1,001 rands and 90 cents. So this repayment amount has two components. One is a principal component, which we call them as principal component, right? Principal component. And the second component is the interest component, right? So on the first of February, I repay this much amount. My principal, this balance is also called the principal amount. This balance is also called the principal amount. So this is my principal repayment. This is my principal. Why is like this? This is my principal repayment, and this is my interest repayment. And this balance is also called principal outstanding. So my balance is not reduced by 1001 rands. This actually I am calculated using an spreadsheet. So this is I am not reducing the 50,000 is not reducing by 1000 rands. You can see here is only reducing by 689 rands. So if I add these two amounts, I will get 50,000. Why this now? Because the interest. The bank is applying an interest of 312,50. You can actually see here 50,000 rands times my interest rate is how much? 7,5. 7,5 is monthly, right? By 12. So if I use my calculator, the 750,000 for 7,5 put by 12, it will give me 312,50. You can use your calculator and see if this is the amount that you are going to get. So this is my interest. So this interest will be applied, and therefore that amount is appropriated towards the interest, and only principal amount is reduced. Since the principal amount is reduced, the next month the interest is reduced. You can see here for the second month. Therefore, the repayment amount for the principal is increasing, right? That's what is happening here. So, for this will follow. This will follow for entire 60 months, right? This is what will happen at the end of 60 months is interesting, right? This is happening. So for each of these months, there's a user spreadsheet. What will happen at the 60th month? What will happen at the 59th month, right? So this is my principal outstanding, and I apply the interest for 1 month, and then that is repaid along with the principal, and my amount becomes zero at the end of the 60 period. So that is why my repayment is 60. So this is a very good understanding of the present value, what is happening in the bank account. This understanding may be required when we answer some of the difficult questions.